Hello, everyone. Good afternoon. My name is Jeffrey Gillen, and thank you for attending this session of NextGen Geospatial. So this is the University of Arizona Data Labs Geospatial Data Science webinar series coming to you live from the Weaver Science and Engineering Library on the campus of U of A here in Tucson. And so today's session is going to be all about deep learning. So let me share my screen here. Let's share it to something different and we'll go ahead and keep rolling. Okay, here we are on the course website. Michele, my assistant, will put in the the course website URL here in the chat in case you forgot where it is. So yeah, so this is the home page, and like always, we do something different for about an hour every week. Try to show you some new tool. Most of it's open source, something that hopefully they're not teaching in accredited classes. Today, we're going to talk all about deep learning. So we'll go down to the schedule for today. So it is September 17th, 2024, and we're going to do deep learning for aerial imagery, and we're going to use a tool called DeepForest. So I'll go ahead and click into that. All right, so here's the course content. So I write the content for people to step themselves through asynchronously. So please don't try to read all the text as I'm going through it. Really, just pay attention to my words, and I will highlight anything that I would actually like you to read. Okay, DeepForest summary. So what are we doing? Okay, so today I'm going to share with you a Python library. It's called DeepForest, and it is a specific algorithm for identifying tree crowns and also birds from high resolution aerial imagery. So it works well with drone imagery and also high resolution airplane imagery. So it works really well with pixels that are kind of in the centimeter range or maybe even millimeters. So things that are really high resolution, it does very good at detecting objects from the air. So DeepForest is so it's built on top of something called Pytorch. Pytorch is globally probably one of the most popular frameworks for artificial intelligence, neural nets, deep learning. And so that's what DeepForest is built on. DeepForest, though, it makes it a little simpler to use because Pytorch itself is a complex Python library. There's a lot to it. Thank you, Michele, for posting some stuff in there. Appreciate it. So Pytorch itself is complex, and so we're trying to make it a little simpler for the remote sensing researcher, for the ecologist, for the person interested in forestry, for the person that's interested in identifying different types of vegetation. And so DeepForest builds on top of Pytorch, but simplifies the interface and the types of commands you can run. So it makes it a little simpler. It's actually quite easy to use. So DeepForest is a Python library. It also provides us with a pre-trained model. So it's been already trained on probably hundreds of thousands, maybe millions of trees already. And so you can just take the model that they have provided and just run it directly on existing imagery. And it should do a pretty good job of identifying a tree. It's not specifically going to identify different species of trees. Right now, it's just tree. And so that tree could be an oak tree, it could be a pine tree, it could be a mesquite. So currently, it has just been trained to identify tree, whatever a broad category that you want to put into that. So that's where I would start if you're trying to use DeepForest. You take the stock model, the pre-trained model, run it on your imagery of interest, and just see how it does. All right, and then chances are it's not going to be perfect or exactly what you want to do. Chances are it might have false negatives or false positives with its tree identification. And so if that's the case, we can add a little bit of our own training data, and then we can fine tune the model. And then so we can change the model just a little bit to then be more accurate on your specific data or your specific problem or your specific vegetation that you're trying to identify from the air. So we're going to do all of that today in a nice, easy to use Jupyter notebook. So yes, how does DeepForest work? DeepForest is a deep learning convolutional neural network. We don't really have time to go into the theory of exactly how that works, but I've posted some really great resources for you. Here, I have 4 different videos that are really great YouTube videos that can help explain it and show you visually kind of how convolutional neural nets work. They are at first a little tough to wrap your mind around. It might take several plays through to kind of get the idea. But the general thing is that we are trying to replicate how the human can easily identify objects and images. So if I look at these 3 images here, these are images of trees, from the air, very high resolution. They're probably a centimeter or 2 in resolution. And the human has no problem looking at that and being like, yep, those are trees. And then obviously, a human can look at them and tell you probably that these are 3 different types of trees. So on the far left, we have ponderosa pine. In the middle, we have a mesquite tree. And on the far right, we have a willow. So how did my brain and my vision, how was I able to just easily identify those things as trees and that they are different types of trees? Well, the magic is in our brain. And so that's what the convolutional neural network is trying to more kind of be an analog to how humans identify objects. And so we are getting away from analyzing a specific pixel. We're not looking at an individual pixel and seeing what its color is to try to figure out what it is. Similarly, we are not grouping pixels based on similar color into an object, what we call it object-oriented. We're not really doing that either. When it comes to really high resolution stuff, both pixel-based and object-based are both likely to not do so well, probably fail when it comes to consistently identifying trees in high resolution imagery. So the solution to this is something called convolutional neural nets. And I implore you, please check out these videos. They are really great. All right, so that is really all the theory we're really going to do. So most of the rest of today's session is just a hands-on, actually running Python code. But don't be afraid. We're going to make it nice and easy for you. So I have pre-built the Python code, and I put it into a Jupyter notebook. And so if you have never used a Jupyter notebook, it is, I would call it, it's simply an environment to run Python code that you do through your web browser. I think that's kind of the simplest way to put it. And so 1 through 5 here, this is what we're actually going to be doing in this Jupyter notebook. So first, we're going to take the pre-trained DeepForest model, like the one that's already been trained by the DeepForest guys, and run it up against 4 or 5 images that I provide and just see how well it does. Okay, and then we're going to bring in some training data that I have already created, and we will fine-tune the model, and we'll see what the results are after that. We'll redo the classification, we'll do the training, and we will actually see if the fine-tuning improves the model or not. Let's see. Yeah, we will output and assess a little bit of the quality of our predictions, like how good did we do? And then finally, we will talk about how to upload your model and share it with the world on a website called Hugging Face. I know it's kind of a funny name, but Hugging Face is I call it kind of like the GitHub of machine learning. GitHub is a place on the web where you share computer code. And Hugging Face is a place on the web where you can share models, machine learning models that you've created, or you can share training data sets or other things like that. So GitHub is a pretty good analogy for what Hugging Face is. Okay, so I would love for everyone to click along. And there you have a couple options. Well, if you want to click along, I would suggest doing this first option. We're going to run the Jupyter Notebook in Google Colab. So you have a Jupyter Notebook, which I said is just running Python code in a web browser, but that notebook can be hosted or served on any computer. It could be on your local computer, it could be on your friend's computer, or it can be in Google's computer. And so we are using Google Cloud in a Jupyter Notebook environment that Google calls Google Colab. And so we can start up an instance or a virtual machine of Google Colab with basically one click. And so I'm going to go ahead and do that. The other option is to run it in Cyverse. And I'm not going to do that demonstration today, but that's something you could do on your own time if you're interested in getting a little bit more computing resources. So Google Colab is really great for teaching, really great for initial testing of things. But if you really want to do production and really want to do research, you will run out of free compute allocation very quickly. And then you'll have to pay Google for the pleasure of using their computers. And so Google Colab is great for testing and teaching, but if you want more computing resources to use this more heavily, please check out Cyverse or contact myself, Jeff Gillen, or Michaela Licosi on how to get access to and use this in Cyverse with CPUs or GPUs. Okay, so I'm going to go ahead and start up Jupyter Lab in Colab here. Okay, so what you see on the screen here is Google Colab, and this is a Jupyter Notebook. And everything you're seeing here is a pre-made Python code that I have written to show you this demo of DeepForest. And so as I go through this, this is not a great time or place to learn Python. So please don't get hung up in what exactly did that line of code do or what is that exact command. I'm basically going to talk about the big picture of what the snippets of code are doing. Basically, yeah, just the big picture. What is each thing doing without getting kind of bogged down into the minutia of the syntax and the exact code that's on the screen. So the first thing I'm going to do is connect. So I have logged into Colab, but I actually need to connect to a runtime. And if I hit connect here, I am going to connect to a Google Cloud computer, and I believe it's going to give me GPU access, T4 GPUs. Okay, looks like I'm ready to go. And what's interesting, you can always click on view resources and you can see your memory use, your GPU memory use, and how much storage space you have on disk. And when I'm actually running things, I'll probably click this on and see if I'm about to run out of memory or if my application is about to crash. Okay, so the first thing we do in Python in general is start installing things that we need, installing Python libraries that we need to run. So we're going to use DeepForest, and hey, there's a Python library called DeepForest. So I'm just going to go ahead and run it. And everyone else online, you should just be able to click along also. So pip install, that means I am downloading the DeepForest library using a package installer called pip. And hey, it looks like it was successful. I've now installed the library that we're going to use. Okay, after I've installed it, I'm now going to import a whole bunch of different packages into my computing environment. That just makes them ready to use. And if I'm going too fast for you, this is recorded and it will be posted in our YouTube channel. Usually takes about a week or so for us to get it polished and up on YouTube, but we will get it up so then you can follow along at any pace you want. Okay, I have imported and brought into memory the different tools I'm going to use. All right, next up is I'm going to bring the pre-trained model that DeepForest provides. I'm going to bring it into our Python session. Just click play here. And so this model is actually sitting on GitHub. And so you can use GitHub as well for hosting machine learning models and computer code. Looks like it's 130 megabytes in size. So I'm going to this website right here, github.com/ecology/DeepForest, and I'm bringing in that model into our Python environment. So yeah, to remind you that that pre-trained model that we just brought in should already be able to take an image, look at it, and identify trees and put a bounding box around what the algorithm thinks a tree is. Okay, so let's test it out. So I have 1, 2, 3, 4. I have 5 different test images. And I believe these are all from a drone. I have flown a lot of drones in my life and collected a lot of imagery, so they make a great test set. These are non-geo-referenced images. So these are just raw JPEG drone images of some kind of tree. And so by clicking this, it's going to run the code to grab those images. They're currently in Cyverse, and so I'm going to download them to my virtual machine here. And that's what this code snippet's going to do. Let's go ahead and do that. All right, and if you look at the output, it's just going kind of line by line and saying, hey, we downloaded that image. It was 8.1 megabytes. We downloaded the next image. It was 436 kilobytes. And so anything that I download to my virtual machine, I can see by going over to this folder. And so here's my disk space. So here's my storage. That's all right here. So I've got 1, 2, 3, 4, 5 different drone images. By the way, Michele, how's the sizing? Do I need to make it bigger at all, or is it readable?
Maybe just one
click.
one bigger.
Okay.
Yeah.
Like that. Okay. Okay, so we've brought in our pre-trained model. We brought in images to test it on. Now let me just try a few of them. Let's skip this one here. That's just going to make a table. You can do that on your own time. Let's just do the visual. So by clicking this snippet here, it's going to take the pre-trained model, run it over one of my drone images, and then put bounding boxes on what it thinks are trees. Okay. This is a drone image of Paradise Valley Country Club up in Phoenix, and it's got a lot of mesquite around hole number 17. And so I just gave it that image, and then it went through and found what it thought were trees. And yeah, you can see that it was successful in some cases. And then there's a lot of like smaller shrubs that it does not appear to have gotten. That's okay. Let's try a different one. Okay, it's interesting how the thickness of the boxes is different. Not sure why, but this is a drone image from Santa Rita Experimental Range, just south of Tucson. And these are all mesquite trees. And so, yeah, you can tell that it's partially successful. It identified some of the mesquites and then some it did not identify. Let's try, what ones do we have here? All right, this is an image from a pecan field over in San Simon, Arizona. And these are immature pecan trees. These are small little like pecan seedlings. And so it looks like it got some, it missed a whole bunch of them. How many I have here? Yep, that's one. Okay. We'll try that. One last one we'll look at, see how well it does. Okay, this is a drone image very near the ski area on top of Mount Lemmon. And so these are all like pine trees and fir trees. And so yeah, it looks like it's getting some. You know, it's not perfect, but it looks like it sort of works. Dan, why did it identify swimming pools? I don't know. um, maybe swimming pools look like trees from the original training data set. I don't know. So the idea then is if it is creating false positives is to train it more for your specific area of interest, and hopefully we can get rid of some of those swimming pools. Okay, so though that is running the algorithm on an ungeoreferenced image. Now let's try it on a georeferenced image. I'm going to hit play here, and it's going to download a GeoTIFF. This is, again, a drone image of the golf course, but it's a much larger image. It is an orthomosaic. Okay, so it downloaded it. Great. Yeah, I do have to run that. Okay, so now we are doing the prediction. We are taking the pre-trained model and we are predicting it across the bigger image. And let's look at the resources. So I'm looking for a spike here to see, you know, how much compute I'm using. The GPU is barely registering, but the RAM is starting to climb a little bit. And the goal is to get through this teaching without the RAM expiring and crashing the session. I only get 12.7 gigabytes. That is in the remote sensing world is not a lot. Okay, so it says I have 3,000 trees. That's can't possibly be correct, but let's take a look at what it did. So this code snippet is simply display. Show me the image and the bounding boxes.
Take some time.
It is taking some time. There we go. Okay. Wow. Okay, so this is our orthomosaic. So it's an image that's, you know, a mosaic of hundreds of drone images. It's for an entire hole, number 17 at Paradise Valley Country Club. And every yellow box is supposedly a tree. So I think it's overcounted. It has gotten a lot of the trees, but several of the trees, it put like 10 boxes or, you know, on one tree. So it is like grossly overcounted. That's okay. So that's what the pre-trained model does. You're going to take You're going to apply it to your data set, see how well it does. And then we're going to get some training data and see if we can make it better. Okay, improve model with training. Let's go back to this course material. So at the bottom of the course material, I have a tutorial on how you would create training data, or you could also call it labels, imagery labels, how you do that using QGIS. We're not going to go through that now because that does take a little bit of time, but it's easy to do. You can do this in ArcGIS also. The idea is just you go around an image and you put a bounding box around the trees that you want to identify. And then we can take that as a shape file, or probably a few different file types, and then bring that into our Python environment to serve as training. So yeah, please do check out this this tutorial for how to label imagery for training and how to do it with QGIS. If you've never used QGIS, it's like ArcGIS a little bit, but it's all free and open source to use. You can download it anywhere on any computer. You can actually launch a version of it in Cyverse if you want to do it that way, or on your own desktop. So anyway, it's a good free alternative. But if you already have a license to ArcGIS, we could probably do the same thing in ArcGIS. All right. Let's go back to our notebook here. Okay, so now we're going to go through kind of how do you do the training in the notebook. This code snippet here, this is essentially going to bring, it's going to tell you what image we're going to use the training. We're going to train with that same golf course image. And then I'm going to bring in a shapefile, which is what these four things are. So you can see the .shp. So those are bounding box shapefile that has a whole lot of trees that I identified. So this code snippet essentially just brings that information into our Python environment. Okay, and it takes, less than a second to do. If I look in my my storage here, you can see that here it is. So golf train UTM, that's the shapefile we're using to train.
Does that, by the way, get added to the pre-trained data, or is it a separate training line? So in other words, the model will operate on the new training data set, or gets into the other one?
It's going to take, so the question was, does this training, is it new separate training, or is it training on top of the already pre-trained model out of the box? It's operating on the pre-trained model out of the box. So we are using all that training already. It's been trained on hundreds of thousands of trees, and we are just taking ours and just doing like the final little bit of training to hopefully tweak it, fine tune it in the direction to make it better for your trees that you're trying to ID. This code snippet that I'm running here is simply going to show us visually what the training boxes look like. So it's a pretty modest data set. Eventually it'll show us. And I'm watching my RAM here. It's not looking good. Yeah. I don't know why this is taking so long. Yeah, yesterday this took about, I don't know, 5 seconds. There we go. Okay, so this is the training data that I'm using. I went into the golf course using QGIS and I put bounding boxes around what I thought were trees. And so it's small, it's, I don't know how many are in here, like 25 or less. It's not that big. And so the idea to convey to you is that you don't need a million trees to make your model better. You can have a much smaller data set. And this is probably not enough trees, as a demonstration, but it can show you that it can still kind of work. Okay, so that's what my training data set looks like. Okay, these next couple cells are just simply, you have to take the shapefile and convert it into something so that DeepForest can understand it. Something called an annotation. Okay, we can just keep going. Do I really need to show that? Probably not. Yeah, I should probably click it anyway. It might have a variable in there that I need later on. And hopefully it doesn't crash the RAM in the process. Yeah, it's taking a lot longer than it did the other day. But hey, live demo, folks. You know what? I'm gonna kill it. Die, die. Yeah, look how close it is. View resources. I don't know if I'm gonna get through this, but we'll try. So what I'm looking at here is the system RAM. So once I get close to 12, our session might end. All right, that wasn't a very important cell anyway. Okay, what this cell does, it is going to take our so we have a big orthomosaic that we're using as training, right? We're going to chunk it into smaller pieces. Why? Because I think that will save on memory. It becomes more efficient. Instead of using one giant image, we're going to break it up into smaller, I think 1000 by 1000 pixel images. It's just kind of the mechanics of how we do the training. Yeah, I have a little thing here like this chunking will prevent running out of memory. Well, we shall see. Yes. Okay, it did it. And it actually outputs all of these smaller pieces into a folder, into our storage. Yeah, okay, cool. Yeah, so now I'm looking at the smaller pieces as it outputted them. So here's one piece it took from the larger orthomosaic, and we got ourselves a swimming pool. All right, let's keep on rolling. I know some of this is probably opaque to you, but it's more about the bigger picture. Okay, so next thing we want to do is take our training data set and break it into training and validation. This is a very common thing you do in remote sensing, or really in any kind of modeling procedure. We have data that we use to create the model, and then we have separate data that we do not touch until the end to then test how good did we do. And so that's what this button is going to do. Let's go ahead and click it. Okay, so there are 67 training crowns, like tree crowns. There are 67 of them. And then there are 14 test crowns. So I did a 75 to 25% split. All right, so that means we have 14 test, trees to know like how well did we do. Wow, my RAM is really hovering on the edge here. How do I bring that back down?
Well, things are stored in RAM. I'm not gonna.
Yeah, let's not go into it, but okay. All right, here's another step we have to do. Not that important for the bigger picture. We'll just keep on going. Okay, we finally come to the actual training run, like the big exciting part. I'm not going to go into all of the details. So these are just parameters for the training run. For instance, we are using the main DeepForest model. That's the model we're using. We are using GPUs. What else? We are bringing in the training data. We're bringing in the validation data. And so this is just setting the parameters to start the training run, but then we have to actually hit go. So this should just take a moment. And then the next step is where it's going to crash. Yes. Okay. Train the model, exclamation point. So this is the big computationally heavy step. This is why AI is expensive and the big tech companies have these giant data centers for their AI because this is, yeah, computationally heavy. It's not going to be so much for what we're doing. We're just doing something very small here, but it will start to use the GPU a little bit more. And if I were a betting man, I would say that it does not make it through. So I'll just go ahead and hit go. And we should be able to watch the progress as it goes through what we call epochs, which is a cycle all the way through the data. It's going to do 3 or 4 of these epochs. Hopefully people that are following along have more RAM than I do. I did get through this whole thing the other day.
Oh, yeah.
Missing a variable fine-tuned model.
This model.
Which step are you talking about, sir?
Yeah.
This one here? Okay, yeah, I haven't got to that one yet. Ah, if I run fine-tuned, it doesn't work. Is that right? Yeah, okay. Yep, I get it. Yep. You're right. It's probably just model. It is model. Yeah, I was monkeying with this yesterday and I must have forgot to fix a little part of it. Thank you for pointing that out, sir. Okay, did we make it all the way through the training run? I believe.
Yes,
Yeah, thanks, Bruce. Thank you, Bruce. Okay, so we've taken the train data, we have taken our stock model, we have fine-tuned it, which hopefully makes us a better model for the thing that we are trying to predict, trees on our image. So I'm going to probably want to change this to model. That was an oversight on my part. Visualize a prediction after model tuning. Okay, so we are now testing it again on that same golf course. So we're doing the prediction. Okay, it looks like we have way less trees predicted, which is a good thing. Okay, it's still going. Okay, great. It finished. Now I'm going to display it. And hopefully the idea is that our predictions are better than what they were. Yeah, your session crashed. Yep. Your session crashed after using all available RAM. Yes. Yes, I'm sure Colab Pro has higher RAM resources. Yes, I probably have to pay for it. Okay, so that's the case. So it must have, yeah, it resetted the entire session. Man, we were so close. Okay, so in the interest of time, I'm not going to be able to go back through and prove that this worked. It does work. I just ran out of memory. Next time I'll have to come up with an example that has a bit less, a smaller geospatial image. So yeah, Michaela, I crashed. Did anybody get through it? Yes? All right.
Within
Not really kind of error, but complaining about the model not working.
Hey, Gerardo, you got through it. Excellent, excellent. Yes. Yeah, it's interesting how it won't be the same for every user.
there is images that you might want to put in the chat.
Oh yeah. Okay, how do I do that? In the chat. Thank you, Gerardo. Okay.
You click on it, it will open.
Will it?
Yes, you're looking at on your left.
Okay. My savior Gerardo, he was able to run it and he showed the output from it. So it predicted a whole lot less trees.
Alex Hack.
Okay, Alex. That was Alex. Gerardo did something similar, so I thank you both for doing it. You can see that there is some nuance difference. I think it did improve it. It didn't. It took a tree and maybe it identified like 2 parts of it instead of 7 parts of it. But this was with really small training data set to fine tune it. So in general, I will declare victory that this actually works. Okay, let me get off this. Okay, it is 2:45. So I got through mostly what I wanted to show you guys today. The rest of this Jupyter notebook is kind of like administrative stuff. You know, how do we output and save the prediction results to other places? Let's see here. So output and save prediction results for each image crop. Okay, so an image crop are the smaller little, the smaller pieces that I made before I did the training. And so you can actually output those and you can look at it and you can see the bounding boxes around the trees. I'm not going to be able to go through the quality because I was not able actually to do it. So we will keep going. The rest of it is save and load the fine-tuned model. And so this is input and output. So once you've done this fine tuning, how do I get it out? You know, how do I get it out of Colab? And that's what this this little snippet is going to do. It's going to save the Pytorch model that you've created. It will save it here in your storage. And then you can actually just take anything in your storage here and download it if you want. And so that's a way to get what you've created out of Google Colab and use it in a different setting, perhaps. You can also bring an existing model into environment. And so perhaps you have another fine-tuned model from somewhere else. You can bring that in. Box precision. Thank you, Dan. Yeah, so there are different ways to assess it. Box precision is one. There's something called intersection over union. And that's another way to assess how accurate do we do things. And I'm sorry, I'm not gonna be able to visually show you that. But the notebook and all the different snippets here should all pretty much work. Yeah, and if you have questions about it, please reach out to me and I can help you through some of it. The final thing I wanted to leave you with was Hugging Face. I think I mentioned earlier that Hugging Face is kind of like the GitHub of machine learning. So it's a website. Here it is. And if I go into, I'm in my profile, I can go to my profile here and actually have different repositories where I can host machine learning models. So for instance, I have a repository called DeepForest Fine Tuning. And in here, I give a kind of a description of what I've done, that I've taken DeepForest as kind of the base, and then I took my own training data. And so like GitHub, Hugging Face is a place to share what you've done with the world. Once you've made a great machine learning model, the next step is to put it on the web and share it with your colleagues. It's a beautiful thing to collaborate on something like this. And so the code in this notebook can help you do just that. We can use Python code to save models directly into Hugging Face, or to import models from Hugging Face into our Colab Python environment. So you can do input and output just right here, which is really nice. Yep, so I can, save fine-tune model to Hugging Face. And then you can download them all from Hugging Face and bring it into Colab. And so that is the tutorial, folks. Sorry for the crash. I was hoping to get through it, but it looks like some of you did, and that's a fantastic thing. And so we have a couple minutes for any questions. I will stop my sharing here. Okay, so we have a couple minutes. In general, does anybody have any questions about the DeepForest Python library, how we use it in Google Colab? I know there are lots of details about the Python code that I did not go over. That's something that we could talk about offline, probably a different time if you're really interested. But hopefully this is just kind of a nice kind of gentle introduction to how to get into deep learning. It's really not that hard. A lot of the heavy lifting has already been done for us by the people who invented these things. So we very much appreciate that they invented it and gave it to us to use. So I'll entertain any questions or comments.
So, you said that we could run or have done the same thing on Cyverse, right?
Yes.
And there won't be like the limitation of what Colab does, right?
Yeah, so Kamal's question was, can we do this in Cyverse as opposed to Colab? Of course. Yeah, on the coursework, webpage, I show you how you can launch Cyverse. But the way that we have you launch it is just using CPUs. If you're doing a big training run, big data sets, you're probably going to want to use a GPU resource. If you're interested in using GPUs on Cyverse, come see us. We can help you out. But because they're limited and in such high demand, we don't just make those public for the whole world to use. But if you want to use them, let us know. We will help you out.
And the second question is twice in the results in the big training model, and then the one we trained, there was still a lot of misses that kind of obvious, like a swimming foot, or something. Like, how do you go about addressing those? Like, is it more training or is it something special that you have to do to get rid of that stuff?
To be honest, I'm not quite sure yet.
Okay.
I haven't used DeepForest enough to know like what is a great best practice for doing it. I've done it for pretty much what you guys have seen. So I don't think I have any great advice yet on how to do that. I think it's trial and error. I think it's take your training data set, give it a try. If you are missing or adding ridiculous things, I think in DeepForest you can add like non-training objects. Does that make sense?
Yeah.
So instead of saying this is a tree, you say this is not a tree.
Don't mess with this.
Yeah, I think you can add that in as well. But that is still kind of an unknown universe for me. I've not gotten super deep into deep learning. This is this is kind of what I know so far.
Well, what we did, and I'll give you an example of what we do in cases like this, although it's not the same setup, is that we did a mask prior to running the model. Where we created a mask to exclude anything that we don't want the model to mess with, and then you really input the results a lot in that case.
Okay,
It's
yeah.
pretty like a green versus non-green, where it's pretty honest, and can.
Okay, so you added a mask to like your whole image area of places like, no, this
Yeah,
is,
like-
we're not interested in this place. Okay, that's a good idea. Just like, yeah, just set aside, we're not gonna infer or predict here.
Yeah.
Okay. Yeah, that's a good idea.
Here's my hand up.
Yeah, is there a question? Joseph?
Yeah, thanks, Jeff. I was curious, this is just identification, right? It's not like quantification of like the pixels or what pixels are a tree.
Right, this is simply an image, like an object detector. It'll take what he thinks is a tree and puts a bounding box around it. There's other deep learning models if you want to do like the exact pixels that make up the tree, or you want an instance of the tree. You know, there are several flavors of deep learning. This one specifically is just a bounding box or object detector.
Are those a lot harder to train? Do they require more resources or?
I don't think so. It's just using a different model.
Okay, thanks.
Okay, hey, thank you all very much for attending. I appreciate it. We'll get this recorded and put up on YouTube in about a week. Next week, we're gonna do another similar thing. We're gonna do deep learning again, but I'm gonna show you a different Python library called Detecto. Instead of identifying trees, this thing can be trained to identify more like human-made things. We can identify buildings or roads or airplanes or cars, things like that. But it'll be kind of a similar workshop as today. I'll run through a Jupyter notebook and show you guys how to do it, and hopefully I can get through without the RAM crashing.